In this video, I want to show and tell about my experience with Reactable, and what problems I got when implementing fairly complicated UI with it, and how I solved them with Vanilla DOM API. So let me first start with the problem statement. I implemented this table, which is sort of like a spreadsheet for my users. They use this table downloads data from Amazon and aggregates a lot of metrics inside and shows to the user and gives the ability to filter by date range and also by top level filters like portfolios, campaigns. So it's advertising data, but it doesn't matter so much for this specific video. You can search, you can customize columns, you can reorder columns like that. You can resize columns, all of this good stuff. You can also expand the parent rows, and it will show you the child rows that it consists of, and the parent row will always have aggregated data from the child. So if we have like units, this is the sum, the ACOS will be a formula for the ACOS, which is spend divided by sales, and so on and so forth. You can basically analyze the information from advertising and make the right decisions. So this is all implemented in Reactable using the Reactable library. It's over there on the GitHub. It's very popular, as you can see, 22,000 stars. So it seems good, very thoughtful and headless library that I decided to use, and basically implemented all this stuff. So I was very happy with that, but then I found some issues that I could not solve or that could require a lot of effort and time, and still would not satisfy the end user experience that I was looking for. First problem that I saw was that the filters, I have the filters here with by numbers. So they filter by the problem that these filters work by the rows that are not aggregated. So for example, let me just illustrate the point. If we take a look, let's say I have this keyword. I specifically found it because it's a very good example. So it has this sub row which has 327 clicks. And if we look at this row, it's actually aggregated row. So it consists of a lot of little rows with some clicks. So let me show you what I mean. I have this debug hack here. So if I shift click on the row, it will show me the data, and I can basically, it will help me to analyze the data and debug any issues that I have. So let's just say that I have this row, right? And this row, let me just show you what I mean. So let's say I will take for each sub row, I will take the clicks. And you will see that it consists of a lot of little rows with some of the clicks. And the sum of that is over here. So that's fine, right? So I implemented this filter which does not understand this number. It only understands these numbers and filters by them. And you even can see that the maximum number that it's ever sees is 159, which is smaller than that number. If I try to filter by that, let's say, you know what? Let's actually color this stuff and hide everything else, so it's going to be easier for us to analyze. If I start to filter, you can see that, okay, it filters out the first little rows, and then if I continue, if I hit the first smallest number here, which is 16, it's gonna recalculate this. So let me show what I mean. When I hit that, you see it recalculates, so basically filters out this little row, and all the metrics are recalculated, which is bad user experience because users do not actually see. They analyze the data based on these aggregated numbers, so they don't care about the raw data behind that. So if I keep doing that, you will see that that's actually what is happening. So this is the problem that I encountered, and I will later on show you the implementation details and how it all is done inside, because I think it's valuable, because Reactable is kind of cool library, but it doesn't have as much examples. Like it does have a lot of examples with small little features, but when you have all these features combined in one, it's kind of good real-world use case. So this is the first issue that I encountered when building this table, and I could not change it really quickly to correct this behavior for the users. Another issue that I had that also made me think about maybe re-implementing this without React was this performance. So basically, I have date range. So the bigger the date range you choose, the more data this table is aggregating. And I want to say that there is no server round trips for the data. All the data is being downloaded once and kept in the HTTP cache. So whenever user refreshes the page, he already has the data in the browser. So if I pick a larger range of data, right? If I pick like that, you can already see that it's been recalculating, and my cursor is not reacting, so I cannot do anything. If I refresh the page, let's see how long it's gonna take. I'm waiting for the data, and I cannot click anywhere because my main thread is busy. And here we are. So yeah, it's very slow, and if I want to expand now, this it's kind of working okay. If I want to click this and to color the row, you see how long it takes. Well, let's repeat this again. Oh my god, my main thread. Yeah. Okay, so let's try again. Here you go. Let's try again. Come on, it's working, working hard, trying their best. Okay, internet, come on. So as you see, it's a terrible user experience. My tab even crashed for that. So this is what we have with React. And a lot of people were saying that, you know, I'm using React in the wrong way, I don't know React and stuff. Maybe it's true, I don't know. I would like to know the better way. I tried to hire people to help me with this. I interviewed maybe 50 candidates and it was not successful. Like nobody could actually help me with that. Especially React is immutable, so whenever I change a single row, I have to change the entire array to tell the React that this row has changed. So this is the problem that I was trying to solve with vanilla.js. So what I did was went and rewrote the entire thing in vanilla DOM API. Let me maybe just show you the end result, and after that we can go into the code and see the more examples. So this is my local version, which is not yet in production. It's all implemented in vanilla DOM API. It looks very similar. If I refresh the page, it's kind of quick, and let me show you first how it works in terms of correctness for the filters. So let me find, yeah, this is the keyword that I want to test. So yeah, this is the one, and let's see, let's filter out everything else. It has similar data. Let's hide this guy. Yeah, so it also has data here, the same stuff, but it's not, it's a lot simpler. It's just one object. It's actually not the object, it's structure of arrays, but I will come back to this later. And when we filter stuff like this, you can see that it's actually working correctly. So if I put 326 here, it does not filter out, and 327, and now it's gonna filter out. So the behavior is correct, which is good. And basically the functionality that I set up to fix has been accomplished. And then the second problem, which was the performance, let's compare the performance. For example, let's take the June, 1 month of data, right? And I'm waiting. Okay, let's test. This is Reactable. So let's see how it loads. Okay, let's try again. So you see the user experience. Then let's try vanilla implementation for the June. This has been refreshed and re-aggregated. Let's refresh the full page. As you can see, it's a lot faster. Let's go on and pick a longer period for 2 months, for May and June. Okay, Reactable is loading. Okay, it's done. Let's do a full reload. Okay, almost done. Yeah, it's done. And now let's pick 2 months for Vanilla DOM API. And then let's refresh. As you can see, it's a lot faster. Then, if I want to color some row, for example, this guy, I want to color it. This is how coloring works. I'm coloring almost 3,000 rows. Then let's color these guys. I'm waiting. Okay, I'm done. So let me just now go to the code and see specifically for the coloring use case, how it's done in React and how it's done in Vanilla DOM API, just to get more detailed information. So let's go to the code. One implementation is in HTTable TSX, and the new DOM API, Vanilla DOM API implementation is in HTTable 3. The 3 is just stands for, because React I count it as a second implementation, and Vanilla DOM is the third. I know it's a silly name. I'm gonna remove it soon, but for now it's fine. So let's see how the coloring is implemented. Maybe, maybe let me go and make a tour, high-level overview of the entire thing, and then we can go inside. So let me maybe just close this for a moment. So how Reactable is implemented? First, we have a bunch of imports, of course. Then we have a bunch of declarations for constants and classes and all of this good stuff, icons, and then I have my component, which is called HTTable, and maybe some additional components, and utility functions. So this component, if we go inside, let me maybe fold it out like that. So it has functions for downloading the data from the server. I will leave it for now like that because it's a different story. It's also interesting how I done that, but let me just go on. So we have a bunch of hooks for React. As you can probably tell, it's very similar, very like regular React code. I use prefix for React, so it's very clear what is going on and what method I'm calling. So I have like references for scroll container. I have data state for the rows data, for the row colors data, sorry. I have a bunch of states for the date picker. This is all for date picker, and actually this one is for the rows themselves, so that go to the table. And then I in this memo I actually combine all this data and put it into the state for the rows. And then when let me show you the table, how it's gonna be, how it's implemented. Yeah, the next one is actually the mutations. I also use React Query, which is a nice library that helps me with all the requests. Let me find you the color mutation. Color mutation looks very like simple. So what we do, we get the request and we adjust it a bit so it has unique IDs, and then we fetch, we send the fetch request to the server, and server saves the data, the state on the server, and responds with the response. And we take this response and we basically go through all the rows in the table, and we look at the row, and if its color has changed over here, it means that the color is different from what we have. I create a new row and return it. So this is the point of React. Like, you have to go through all of the elements in the array. If you mutate any array, any element in the array, you have to mutate the entire array. And if array is big enough, you got performance issues. And then when I get a new array, I set it into the React state, set rows and set row colors. I have these two states. And this is what is not performing well in terms of runtime performance. And yeah, I have a bunch of different states for filters and stuff, and the table is being initialized over here. So I pass the data from the row state, and then I pass all the states for the filters and column sizing and ordering, all this good stuff. And then I have like some functions that react to the changes and stuff, and a bunch of models. And one more thing that I wanted to point out, that this table remembers all the states. So if I refresh the page, it remembers everything that happened. And actually this table also remembers everything, even the filters that are happening right here. If I refresh it, you can see everything is saved. So for the user, it's very important. In like my customers, they need this kind of behavior from their spreadsheet. And that's why I need, I do the server request to save the data on the server whenever something changes. So this is how it works, and I call the color mutation right here when I actually not, yeah, in this place I also call, because I have this way of coloring, so you can actually bulk color stuff. And but the interesting thing that the actual call is over here. I take the color of the row that's been clicked. Then I call the mutation with the IDs of the row, and I take the IDs from the ReactTable, and so on. And what is also interesting is that filters, they behave like in a spreadsheet actually. Like the real Excel functionality is here. So for example, if I take, let's say we take the same keyword that we used Where is it? I don't know. We can take any one actually. Like we can take this one. If I filter by clicks and I have these rows colored, so I have filter here, green color, right? If I filter those rows out by the number of clicks, actually, maybe I have some other, yeah, I have some other green rows. Let's hide them for now. Yeah, so now the setup is correct. So the only green rows that I have, let me maybe start again. You know what? I have some more green rows here. Yeah, now no green rows in the table. If I color the rows, the filter has the green row, the green color now, because now there are green rows in the table. If I filter by the number of clicks, then the filter green row disappears because the currently filtered table does not have any green rows in it, right? If I filter back, so they appear here, then the filter has this green color again. So basically all the filters impact all the other filters. This is like Excel spreadsheet behaves usually and what people expect from the Excel. And yeah, so I showed you the rough example of how the coloring is implemented. And then let me show you how the vanilla DOM API table is implemented. So let me maybe fold everything. Yeah. So basically I have a main function which is like, very simple stuff. I take the root element and initialize everything, take the state from the server, which is embedded in the page. I load data similarly to what I've been doing with ReactTable, and also initialize date picker and stuff. And after that, I have some models that I use. And because ReactTable forces me to use rows, let me show you what I mean. It forces me to use array of rows because that's how API looks like. And because array of structures is less performant and less memory efficient or less cache CPU cache efficient, I actually decided to use structure of arrays instead. So it's a lot of fields which are arrays, and this is what I use for vanilla approach because I can, and nobody's forcing me to use array of rows. So that's what I do, and then I actually initialize everything. And the way I initialize, actually, I have this function RenderInitial, which is just creating a bunch of top level elements in the document and not attaching them yet, just creating them in memory, and that's it. And then I have a code that puts everything inside of these elements, so let me show you what I mean. Function main. I have, let me fold this like that. So I have refilter by date and reaggregate and render. I don't use any OP bullshit, so it's like that. So what it actually does, if we look inside, refilters SOA Arquero by date. Arquero is a very nice library that I use to aggregate by date, filter by date. And basically, because my source format for the data is binary, it's Apache arrow format. Let me show you what I mean. So these are the rows that client is requesting, and they are usually coming from the HTTP cache. And the way it looks like is like that. And this is Apache arrow format, so it's basically a structure of arrays encoded in a binary format, and that's why it's so small here. This is for 1 month of data. So original data was 2.7 megabytes, but it would be even more if I didn't use structure of arrays. And this is for 1 month. And I request for the last 6 months, and then concatenate them in one big structure and use arcvaro for that. And yeah, I just refilter by date, and then I have this function which is actually aggregating stuff and groups by whatever I need them to be grouped by, you know, just basic loops that prepare the data and convert them to structure of arrays. And yeah, this is like basic initialization. It's very procedural style, as you can probably tell, and that's when I have in this place I start to initialize the DOM, and I start with top filters, meaning these guys. So I can actually like disable some of them, and table will reaggregate according to what is available in this filter, and all the rest of the filters will also refilter based on what is available. As you can see, portfolio is changing the number of portfolios available for this specific match type. And this is the DOM initialization, and it looks not very nice from the first glance, because, you know, I come up with this practice of I create an element, and then whatever is inside of that element, I put it in the block. So that way it's easy for me to understand what is going on here, and it becomes kind of manageable and not as terrible without blocks. And yeah, this is basically how it's all done. Let me maybe then go to the color use case that I have. So usually whenever I react to some action from the user like that, I usually have the function named HandleInput. So whenever a user clicks on the color, I call this function HandleInput color click, and I can show you where I invoke it right here. I have a listener on the click, and I invoke the function. So that way it's very easy for me to go and understand, to find a place where it actually handles the action. And all the actions are very simple. I just calculate the next state after this action. I save it on the server, and I re-render stuff. That's it. This is the entire implementation, and it's fast, it's simple, and it solves the original problems that I had before with React. So this is basically the entire thing. Let me maybe tell you a bit about statistics here. So this implementation is almost 4,000 lines. It's one-to-one implementation, so everything that is implemented with React is also implemented here, with slight differences, maybe like 10% difference in functionality, because when I was rewriting, I saw some places where I wanted to make them better, but it doesn't actually have any significant impact on the end result. And the Reactable, the amount of rows it has, let's see how much it has. It has 1,300 lines, but it's not only one file, it's actually more than one file. It also is inside of table.tsx, some more additional functionality. It's 500 lines more. So in total, it's 1,800 lines, but it also uses a library for ReactTable, right? And this vanilla DOM API does not use any library for tables. So and if we go to React table and count the amount of lines in this repository, let's say I want to count only only in the packages I want to count the core package. It's 5,000 lines of code, and the React package is 4,000 lines. So in total, it's 9,000 lines of code just for the library. So basically, that's how the lines number compares, and the end result that you can see by yourself. The performance, the correctness of the filters, and all of that. So I fixed the problems that I had, and I actually got a better runtime performance as a result as well, and a more maintainable code actually. Someone can argue that it's less maintainable, but it's another story. Like as you can see, the functionality is almost the same. You can do all of this stuff as you could before. You can resize stuff and so on. And yeah, this is basically the thing that I wanted to cover and compare the experiences and the results that I got when going from React to vanilla. Thank you.